Hello grade 7 and welcome back. We have explored finding the area of rectangles. We've moved on to parallelograms and from there to triangles. And now we're going to consider this guy who is a trapezoid. And we have a nice way that we can find the area of one of these as well. First, we really need to know what the definition of a trapezoid is, of course, and I think we have an idea in our heads, but just to clarify it a little bit, a trapezoid is a figure that has one set or one pair of parallel lines, and it is also a quadrilateral. So a four-sided figure in which there is one pair of parallel sides. The other two sides are not parallel. And today we're going to consider how we can find the area of this figure. A couple of things to note. One is we can sort of see that this figure has a base, just as our triangles and parallelograms did. It also has a height. Notice that I have drawn the height at exactly 90 degrees to the base, and that's always a requirement for your base and height to get the area of any geometric figure. We know from trapezoids from parallelograms, that the angled sides are really not very helpful in terms of finding our area. And then the last thing to note for our trapezoid is I've put in here a thing called T for top. In other words, the length of the top of the trapezoid. And we'll see in a moment that that does figure into getting the area of this thing. The key lies in the fact that for any given trapezoid, it doesn't matter how you draw it. You can always take an identical trapezoid to that one, which I just had underneath it, and you can place it in the right orientation, and what you will get is, well, maybe you can take a moment to figure it out. What is that figure? And if you said parallelogram, you're absolutely right. Now, how do we find the area of a parallelogram? Well, you need the base, but unfortunately what we have here is only a portion of the base, and we need a height. So if we could just figure out this piece, we would be able to get the area of this entire parallelogram, and then if we just cut that in half, we'll have the area of our trapezoid. Well, the key to that is to look at where this extra piece actually came from. And let's put it on top so we can see it clearly. That piece is this. So the extra portion along the bottom, this one, is exactly the same length as the top of the trapezoid. So this portion here is T. Now, sorry, drawn that way. So if we consider the full base of our parallelogram to be the entire distance across, then we can think of it as being B plus T. And if we take that sum and multiply by H, we're going to have the area of the parallelogram. And if we cut that in half, we'll have the area of the trapezoid. So there's the key to the formula then. The area of a trapezoid is the bottom of the trapezoid plus the top of the trapezoid, all multiplied by its height, and that entire thing divided by 2. That is the formula for the area of a parallelogram. Now, it's important that these two be the lengths of your parallel sides. It cannot be these diagonal sides on either edge. But that is the formula. And to sum very briefly, what we've done is discovered that all trapezoids are half a parallelogram, and that that parallelogram has a base that consists of the bottom of the original trapezoid plus the top of that trapezoid. So that gives you the length of the entire base, which you then multiply by the height to get the area of this figure. That's what we've done here. And then divide by 2 to get the area of just this trapezoid. So that's how that's done. So to take an example, let's imagine that the base in this case was 12 centimeters. And let's imagine that the top was 5 centimeters and that we had a height of 7 centimeters. Then we do our usual formula and then substitute. So b becomes 12 plus a t of 5, all multiplied by an h of 7, and then divide by 2. So the 12 plus 5 gives us 17, which has to be multiplied by 7 and then divided by 2. 17 times 7 is 70 plus 49, which is 119, which has to be divided by 2. And that'll be what? 59.5 centimeters squared for the area of this trapezoid. Now what can happen when you go on to do these exercises with either trapezoids or with triangles is sometimes they will give you the area and ask you to draw one that has that area. And so I'd like to begin that using a triangle with you today to show you a little trick to getting that done. So let's imagine that you were told a triangle has an area of, say, 20 centimeters squared. Well, the key to this is actually to get your dimensions by doubling that 20 to a 40. And you'll see why in just a moment. But if I can think of any two numbers that multiply to give me twice this, I really have the key. So what two numbers multiply to give us 40? Well, it could be, let's say, 5 and 8. So I could say the base of my triangle is 8. The height of my triangle is 5. And we'll see the area will come out to exactly 20. So if that's the base of 8, and forgive the quick drawing here, base is 8, height 5. Let's get the area. We know the area of a triangle is base times height divided by 2. In this case, 8 times 5 divided by 2. And now you can see why we were aiming for that 40 initially, because it always ends up getting cut in half to give us the 20 centimeters squared, which is what we wanted. It's very similar with a trapezoid. Let's say that you had a trapezoid whose area needed to come out to the same thing. Let's say the trapezoid area is 20 centimeters squared. Well, first thing we're going to do is double this. So we're looking for a target of 40. But what we know about trapezoids is that it's always the bottom plus the top of the trapezoid that gets multiplied by the height. So let's say that get our two numbers for 40. Again, it could be 8 and 5. So let's say that the height of this thing is 5. Well then, this plus that has to equal the other number, which was 8. Now this is not to proportion at all, obviously, but one possibility would be a base of 6 and a top of 2. Let's see if that works out. So the area of a trapezoid is the bottom plus the top times the height divided by 2. 6 plus 2 make 8. The height is 5, and we have to divide by 2. And that's working just fine. That's 40 divided by 2. And there is the 20 centimeters squared that we wanted. So when you get asked to draw a figure, either trapezoid or triangle, that has a targeted area, remember to double it first. Then work out the numbers that multiply to that double. And this business of dividing by 2 at the end will always get you to the area you wanted. All right, hope the exercises go well for you today, and we'll see you next time.